very much. Thanks, guys. And yeah, thanks for the people who organised this event. They put a lot of effort in. And I also need to thank Dears for helping us. Jess, I don't think she's here, but you may have seen her downstairs, and Julia as well. I think without those two, if it was left to Brendan and I, yeah, we'd be pretty.
It would be bad. It would be bad.
So,
might be on the street.
Yeah.
There would be beer though.
Yeah. Okay, so we're gonna talk about continuous delivery, and how we've been using continuous delivery to deliver solutions for some of our customers. So we're going to break some rules tonight. You only live once. We're going to do some live coding up here. We're going to be pushing some changes, deploying some stuff. So you guys will be entertained. If it goes wrong, you guys are still going to be entertained. So it should be okay, right? So it's continuous delivery. So what we want to talk about to start with, we've got a few slides and we'll go into doing some coding. But to start with, we just want to talk about some of those practices that make continuous delivery possible. So they are really around deploying code and measuring the effects that code has on your customers. Okay. We're then going to go into doing some demo, and we've built a little mobile app, which we hope you guys can participate with if you've got a phone or something. We're going to use you guys as a bit of an experiment just to see how our coding goes and how we're going to launch a new site tonight. So we want to see if it's going to be good. So if you guys could participate, that would be really good. And then give you some takeaways as well. I think if there is a takeaway, it's sort of experiment. Try and experiment as much as possible. I know there's a few guys from REA here. Rich Donnell was good enough to show one of our customers around REA recently, and he made a really good point around it's experimenting not just in the products that you build, but it's also really good to experiment in the way your teams do things as well, right? So experiment in the way you organise yourselves, your processes you follow, and measure all that as well. So experiment not just with what you build, but experiment in how you do things as a company. So that was a good bit of advice from Rich, who's done some really good things at REA as well. Yeah, so we're just going to start by talking about setting the problem scene here a little bit around continuous delivery, and talk about some of the release patterns that we've seen and worked in. Okay, so first up is a single deadline. We've done this before, haven't we, Brendan? It wasn't much fun.
That's what I started doing. I think people still do this, especially banks, of course, because they have a little bit more issues with red tape, I guess you would call it. Yeah, so it's a lot of it's about you do a lot of your design up front. Customer doesn't see anything right till the end. It's usually late. That's my experience anyway. It's not always the case, of course.
And it's really risky as well. Like this is the riskiest way to build software, and it's kind of perceived not to be, but it certainly is.
In my experience, it's usually you're pressured in the beginning of the project. It could feel like you've got everything under control. You've got a nice design. Of course, you've thought about things, and it's not reality. And by the time it comes to the crunch, you are not even close to actually delivering what the customer wants, and it may not even have been what they wanted in the first place. Yeah. So yeah, it
starts out well. There's always some good parties at the start because everyone thinks they're doing really well, but at the end, yeah, I think people get burnt out typically, which is not good for us, and people end up leaving, or most people end up leaving. So yeah, I guess you've all experienced this. We don't really do this much anymore. We don't do this at all anymore, actually. But yeah, that's what we first experienced. The second one is this sort of regular sort of release model, where you may release every iteration or every second iteration. So that might be sort of once a fortnight, or once a month, something like that. So this is pretty good. Like gets you into a really good rhythm of deploying software. I think one of the problems with this approach, though, is that you're trying to build features for release, and then you don't make all those features. So what you end up doing is deferring the release. You say, "Oh, we're not quite ready. We're going to do the release again in next week or the week after."
And it almost feels like it's like little mini waterfalls. So everyone's pushing at the end of an iteration, you might cut corners, like with your testing or whatever. Yeah, so still, it's definitely better than the deadline.
Yeah. So this is less risky than the first one, right? So this works pretty well, but it does have some. You do get some of those iterations that become a bit of a mini death march. But it's been good. We've had some fun. We've done this for years.
Yeah.
Had some good results of this. The third one. There's a big guy from. This is actually who's. I know you're from Haru. Anyone else from Haru here tonight? Okay, so we've got one guy. This is the Haru deploy button. This is kind of one of their modes of deploying software. I don't think it's rigged up at the moment, but not anymore.
Yeah.
So
It blew up.
it was too dangerous. So the third one is continuous delivery. So this is the one that we've been having a lot of fun with. So this is where we kind of ship changes, small changes, very, very frequently, and we even ship stuff that doesn't work or incomplete into production as well. And we'll talk about how we. Is there any more? There's a couple of chairs down the front if anyone wants to squeeze in.
You're about the compression algorithm.
Rolling quite all of these people.
So, but this is really hard, right? So I think what's really hard is like not a piece of software you can install and say we're doing continuous delivery. This is hard because it requires much more sort of collaboration between people. So it's really around not just the devs and testers and BAs kind of working together, but you also need to involve obviously a lot of operations. That's probably the most important thing. Also sort of legal, marketing. There's a number of, everyone needs to come together and do this, right? So in most organisations, it's about breaking down those silos that still exist and that really kind of impact proper continuous delivery. So this is really hard, but it can lead to some really good results. There's also, it's not just a case of devs pushing code out, like a couple of times a day. There's still this level of planning and control that goes into it. So some of our customers think, you guys are just cowboys, right? You're just pushing code out without it being tested, which is really not the case. There's still some planning, right? There's still a lot of, we still have a go no go decision each day, and because we do that so frequently, we get really good at it. So we pull the right people together and say, these are the changes that we're going to be deployed. Does this affect support? Does this affect legal? Does this affect the various people and we make a decision about whether or not we should go or no go. So because we do it so frequently, we just get really good at it.
Well said, Steve.
And you can get it
And
done.
another thing about this, remember, we've done this once before, about 2 weeks ago. That was, we had 45 minutes and we didn't fit it in that time.
Yeah, sorry, I need to go faster. Okay, so we actually like to make deployment just sort of boring, right? Deploying changes to production should be really boring. Make it a non-event, right? It just has to be something that actually the fact of releasing software and the customers getting new stuff is exciting, but the process you go through to do that should be just non-event. So it's all around sort of being able to deploy, okay? So being able to automate, it doesn't matter how you do this, but just automate your deployment. That's the most important thing. And make sure you deploy the same to every single environment as well. Don't skimp on, often people say, well, production is different to my pre-production environments. Don't skimp on those environments, right? Invest money in your pre-production environments. Quite often we see companies that don't do this, right, and they have a pain. But those are the tools that you work with every single day. You need to invest in those pre-production environments. And so the more you deploy, the faster you go, the more experiments you can do. Okay, and that's really, really useful. Really useful. So,
Gabe, this is your company.
Oh, good.
yeah. So we did some
You can talk about this one. So I'm currently at Huru, and we actually do continuous delivery, and it's working out pretty well. The way that we use it is it's not just you push to prod and suddenly push to GitHub and it's in prod. There is a process around it, but it means that Haroon's been able to go into the marketplace and push stuff out really quickly and adapt, all that sort of stuff. So I think it's a bit of a success story. Would you agree? It's part of your process now. Everyone is involved, the whole company. Of course, that's not going to work for every company. As Steve said, it is it's almost the culture of the whole company, not just the dev team. Like a lot of companies will be agile in just IT, right? And then everything around it is sort of still waterfall.
Yeah.
And that's not really going to help. I can't remember what else we were talking about.
Well, this is a hotel and accommodation app. Super competitive, right? You've got the local market, and you've got the international market. So that's really competitive. So these guys need to find a way to beat the competition, be better than the competition, and continuous delivery is one of those kind of pillars, if you like, that enable them to compete. So they're based here in Melbourne. So first thing that we did as a team was automated everything, automated the infrastructure, automated everything really, and that's kind of gave us a good platform. Before we started building any features, we built that platform. And it's a team responsibility, so they've just got a really strong culture around everyone's responsible for doing deployment. And yeah, well, Alan Joyce, CEO of Qantas, did a deployment as well, so that's kind of how high level visible it is that that's just something that they do. And it enabled them to do some really good experiments as well. So they did an experiment, now accounts for 15% of their bookings. So that was just something they spiked in Melbourne, looked good, they started rolling it out across other cities, and now it's 15%. So obviously lots of stuff fails, lots of those experiments fail, but because they're so cheap to do, it doesn't matter, right? The investment is really low, so you can do more experiments, some win, some don't. So. Okay, so once you deploy your code, the next thing about continuous delivery, which is probably the most important thing, is to be able to measure the effects that code has on your customers. So first of all, you need to know what it is that interests you, what's important. So those are your business metrics. So these are around what is it you're interested in, what's your goal? Is it number of visitors, number of people who go to checkout, repeat customers coming back? You need to know those business metrics. And then you work backwards from there. And then once you know what it is you want to achieve, you've got to look for the minimal change, find that minimal change. This is the really hard thing for us to do as engineers. We want to build stuff, right? We think we know what the solution is, so we just go out and build it. But the most important thing is to really cut that back, keep cutting it back till you get to the core feature that you're trying to test your hypothesis on, and then build just enough to test that, okay? And then you deploy that and check the results. So you shouldn't be spending weeks building something, you should be spending hours, maybe a day. Okay, minimal stuff. This is really hard. This is, I think, what we find most difficult of all, is finding that minimal change. And so now we have got a little demo which is online. It's called lastmeme.com. There's not many meme sites around. So we reckon there's a gap here in the market.
You managed to get last me.
We did.
Was it squatting on that?
So this is a little demo we built for this Preza. We did the Preza a couple of weeks ago. We automated everything. We built the site today. We're going to build the whole thing from scratch today, but it took about 15 minutes to build the infrastructure. We're using CloudFormation and Amazon. CloudFormation's worked out pretty well. Has some limitations, but it's good.
Shouldn't it be Inframeme if you did this for last comp?
I can afford to find
this on a mobile. So this is our MVP here. It's obviously very impressive. Single meme. It's quite targeted to you, our audience, or the people at last month.
I like the responsive design.
Check that out.
Oh, look at sensors again. Sensors. Oh.
Twitter bootstrap, that's my go-to for this sort of thing. Yeah, so all our infrastructure's already been set up. This is unfortunate, I don't have a mirrored display.
You can move it.
Yeah, I don't mind that one.
So this is our minimum viable product. We want to figure out whether people like memes on the internet. So this is our first meme, and we just that's it. Right? That's our first feature.
Cool. So other things we've set up as well. We've already got some metrics. The resolution's not awesome, but you can see we've got people actually viewing images. That's amazing. Thank you guys.
We've got
Come on, you put up the URL. What do you think's going to happen?
All right. So we've got a whole bunch of. We're measuring you. And we've also got, so we're using Jenkins for this demo. I'm not sure most of you probably are using CI in your workplace, I'm hoping. Jenkins is free. There's other free ones around as well, but this is the one I'm still most familiar with. Has been for quite some time. What we're using though is the build pipeline, and Gabe, you're very familiar with this particular plugin. This is a very simple version. It's not anywhere near as simple as the Huru one, but you can see we've got unit tests, and then once that completes, we go on to our acceptance test and then a production deploy. So most people won't actually do this, because what this means is if I push code and my unit test pass and my acceptance test pass, then I'm in prod. All right. I trust me for this. But most organisations aren't going to do that, and they'll also have other things in here as well. You might have a staging, deploy, performance, a whole bunch of other test stages. So you've got options. Anyway, so I'm going to do a little push here.
We've got a new feature, have you found?
Yeah.
What do you got?
This one's pretty lame. We'll get there. We're going to do this slowly. Oh shit. Alright. So we don't actually have auto builds just because we wanted to limit things that could actually go wrong. So
Auto deploy, but no auto build.
well, then we can talk. Yeah.
It's all out.
It's delivery. It's how we see. We've got a very fast test suite. Look at that.
It's just X zero, isn't it?
It's true.
It's true.
You've seen my test before. And then it should be deploying. So this little feature it's going to blow you guys away, I swear. We're not ready.
Do we need to sign an NDA?
Yeah. We're going to sell this to Google.
Oh my god, I got a different picture.
Now, there's only a couple, and these are Steve's.
Yeah.
Oh. That's a dad joke there. Sure. Another thing about this, it's not very clever, so you'll get the same thing potentially every time that you refresh it.
But it's an improvement on the last one, right? We've got some
Four.
visitors.
I'm just sitting here hitting reload as hard as I can.
You're doing it for the presentation. Anyway, yes, we go.
I think the measurements work, you know.
Yeah, stuff's going on.
It's working. We can sell some ads on this.
Yeah, exactly.
So that's showing like some business metrics, like just some stuff that active users, images, average views, and then also some operational stuff as well, just in the basic form. It's just using Librado. I don't know. Has anyone used Librado? Anyone? Yeah. It's good. It's easier than setting up than Graphite.
Yes.
About 10 minutes.
And prettier. Graphite is ugly. All right. So I've got to remember my next feature. Something like that. This could go wrong because I stuffed this up earlier today.
It shouldn't go wrong in the tests.
Well, yeah. I'll show you that if you want. So we've got a new feature. So another thing about continuous delivery is obviously if everyone's always pushing code, things could go horribly wrong when it goes to production. So the way that we deal with that is using something called a feature toggle. That's really simple concept. It's basically an if statement around a piece of code, whether or not you want something available to a user, and we use that at Huru pretty successfully. We've got millions of damn things. Yeah.
So you can switch it on in a staging environment and test it or whatever, and in prod it's effectively switched off.
Can you refresh that page, that dashboard? So the only slight bug in Librado at the moment is it doesn't show the annotations for releases. or
Yeah,
deployments.
that's right. Yeah, so we've got something else that's quite nice where it will actually show you when something's been deployed. So that little green line there is a deployment. So if you saw something like with your CPU or something that was going wrong with a deploy, that's probably pretty handy.
Yeah. And obviously zero downtime as well on deployments. That's kind of important if you're doing frequent pushes. You don't want to be any downtime on your site, so you need to think about zero downtime.
And that's a whole other ball game there. More complexity, but it's all fun. We like complexity, don't we? That's why we get paid big bucks.
Where do you work again?
All right. So it doesn't look like much has changed apart from that. That's funny, isn't it?
That's your one, It's a kitten, that's right.
Right. So now we see that, I just activated a feature. It's amazing, isn't it? So now, and I can deactivate, actually I won't show you that just because you guys will probably do it. So now you can actually vote. So that one didn't go random, but I told you that it's not very clever.
So the code was in production, but it was just sort of lying dormant, if you
Yeah.
like, and we can just toggle features on and off.
Yeah.
So basically it decouples that deployment from the release, so product owners still get to say when they want to turn a feature on. So there's still some control over the product owners deciding when they want to expose something to the customers.
Did you just turn that feature off again?
Yes, it just went off.
Someone actually. It was very. I thought that might happen. The last one, no one figured that out, but you guys are obviously. And we can see we've got an extra metric here, which is funny versus stupid. And funny's winning, so that shows the other. Most people thought it was stupid in the last one. I like you guys better.
Easily amused.
And there's beer here too, so that's
Hooray.
all right, so I've got one more little demo, don't I? One.
Yeah.
Got to remember what it is.
What's the other killer feature?
This one. Oh yeah, this. You're gonna love this. This is huge. It's really to illustrate another point. But first, another thing that you have to be aware of when you've got this sort of process is obviously if you want to be able to react really quickly to your environment, having a 2-hour build is going to sort of make this not as valuable. So having a really quick build is ideal. So Huru has like this sort of, we parallelise the hell out of it to be able to do that. It's still not like, it's not the quickest build in the world still. I think half hour?
12 minutes.
12 minutes.
And
Yeah, but all the stages,
sequentially, last time I checked, it was 110 minutes.
Yeah, not ideal.
10%. Yeah, we need faster.
The acceptance tests sort of hold you back a little bit. These ones are really fast, 4.4 seconds, check that out. I could teach you something.
Don't you mean hire me again?
So the other thing, we've already discussed zero downtime. That's with Active Record, this is Ruby, so, or it's actually not Rails, but we don't even have Active Record in this.
It's Unicorn?
It's unicorn. Yeah.
But if you are using something like that, you often have to think of a way to patch your releases. So it's a multi-step process with like removing columns and stuff like that. And you don't want a flaky build. If you've got tests that randomly fail, that can really affect your ability to go to production. So you're really relying on a tool like this is key. So the other thing about this is, so the last thing I did, apart from more memes to be funny, you can't see it on this. We're using A/B testing here. So what we would do, or this is an example of how we could release something and then test
if people like a particular feature. I think hopefully I've got an example of. There you go. All we did was change it to icons. So yeah, I know it's mind blowing. Yeah, it's flat design. Do I like it? Very Apple. Isn't it? Oh, everyone. Very everyone now. So you can vote on those, and from that we could take metrics on what is more popular. I didn't bother to do that because I think we've probably gone over it enough. Yeah.
So how many users did we end up with, and what's the...
How many users? That's a good question, Steve. Active users peaked back then and 109.33.
Okay. What was the funniest meme? Can you?
Yeah.
So just quickly.
We've got. You can't switch this one off either. So I put out the Fox. Oh, you're kidding me? That is the funniest.
No, it's not solid.
Oh yeah, that's broken.
You need to
No,
add a test.
it's in the algorithm. It's the algorithm.
You need to add a test for this.
Funny minus stupid.
Yeah, it is exactly. There you go. That's my favourite.
Alright. We've got a couple of minutes.
Sorry?
Have we got a couple of minutes?
Sure.
Yeah. Alright, just quickly then.
Need to fix that bug.
No, it's actually not a sort, it's a hash. That's why
It's a feature.
it makes plenty of sense.
It does.
Nice one, Benno. Thought it's good to do some live coding.
That's not. That's just pushing.
Just hoping
the infrastructure works.
Okay, so yeah, obviously, don't do this unless you're using version control. Some people still don't use that, which is kind of surprising, given how easy it is to use with GitHub and Bitbucket and all those online SaaS options for source code. Have confidence in also version control everything, right? So it's not just your code, but it's all your infrastructure as well. Right, that's probably key. Configuration, everything, right? And I think that's probably where most people still fall down a little bit. Obviously, you've got to have a lot of confidence in your tests as well. Fast tests and confidence in your tests. It's not just about 100% code coverage, it's about knowing that your tests are going to find the right things. Clearly you need to do continuous integration, so your devs need to be pushing to your master branch frequently. It's not about feature branching or anything like that. It's everyone pushing to doing proper continuous integration. The most important thing is, you've got to involve your operations team here. Your operations team need to be part of the delivery team. That's really important. We don't want to, in the old days, developers would push code and then they'd go to the pub and then the ops guys would have to fix the shit. So that's clearly not the model, and I think we realise that now, and that's why we're obviously here. So talk to ops, that's part of the team.
Be mates.
Be mates. Sometimes hard.
It's also overwhelmed as well. I mean, ops needs to talk to them very early on, not just come at the end of the job, or just show interest at the beginning.
Yeah.
That's easy on. I mean, this is much easier if you're doing it from the start.
Yeah.
To bring it into an existing process. And,
and there's things that ops will bring back to that, and like here where, it worked fine in staging, but it's not working in ops. So let's work on it together. We're a team. Software delivery.
Yeah. And certainly there's patterns at REA where there's a platform which is basically the ops team now provide that platform, which is a really nice model, and that's just like a pass, if you like, and then developers are then responsible for building applications on top of that. So I mean that's a really good model. If you guys don't know about that, then just talk to Colin. Yeah, start small. Obviously, to do this, don't it's just fix the things day by day. Automation is obviously key to start with. Capturing metrics is also really important. I mean, geeks kind of like to capture stuff, but you can't do enough of it, right? So when we kick off stories, we actually talk about acceptance criteria in the story. We talk about its tests, and we also talk about what metrics we're going to add to the code as well as part of the story. And it's fun that minimal change as well. Resist the temptation to go and just think that you're going to build up this solution, which is going to take 2 or 3 weeks. You just got to really cut it back and make deployments missing the word. Make deployments a non-event. That's it should just be boring.
I kind of like it, makes deployment a non.
Yeah, it's a non-issue, non-event.
Anything.
It'll maintain a stable environment, no deployments.
Make it a non-event.
Yo, Steve, did you want to show the
Yeah.
ruin?
Your pipeline are real.
So some books, obviously Lean Startup, a lot of these practices are based on that. Continuous Delivery by Jez Handel and Dave Farley as well. It's another good book if you want to know some of these patterns. And if you just want a good read, this is kind of like a fictional story about DevOps.
It's not fiction.
It's not.
It's a great read. You can read it in a couple of days. It's good. Phoenix Project. And yeah, that's it. So happy to take questions now, or we're going to be around for a bit. So
we'll take a few, just because we're running a bit late on time.
Yeah.
So maybe 3 or 4. That's how enthusiastic you are.
You mentioned having everything in version control, so obviously you can roll the code back, but do you design your schema for the same principle, or rollback, or do you rely on agility to move forward?
for the database you're talking about. Yeah, so that's a hard one, right? Because that becomes that shared resource that it's not kind of easy to roll back. And it's just you just got one database that old apps need to talk to as well as new apps. So that's a much harder. It's a harder problem. It's still solvable, and there's some good patterns out there. That book, Continuous Delivery, talks about some schema migration patterns, but it's basically the good one is expand, always keep expanding your schema, and then at some point you remove old stuff. So it might be always add new columns, don't ever delete a column. I think that's kind of the right approach.
The other approach is to never ever actually talk to the database directly. So have an API layer which talks to the database and owns talking to the database, and you integrate through an API. And that way, if you need to change the schema, version of the API, that way all you need to do is change the version of the API.
Because when you add that thing, the thing that you'd select star from blah will break horribly.
And of course, you'll never need to change this database API, so it'll be fine.
That's right. But at least when you do, you only have to change it in one place.
Yeah.
Okay, so that shifts the problem to a central point rather than scattered all over your code.
Yeah.
Well, the other thing is, if you have a versioned API, then your old software can just request a previous version, and your API just stays the same.
And you can gather metrics over how much of your old version of the API is being used and where it's being used from, and then you can go and shoot that piece in the head.
Just messy.
But yeah, databases are still a bit hard to deal with.
Any other questions?
Just to follow up to that.
Yeah.
It's often a choice between rollback and moving forward and fixing a problem.
Yeah. Yeah.
Which way do you tend to lean, and how do you make that?
Well, it's always better just to keep rolling forward. I think that's your process. That's your process that you follow. So if you start thinking about alternative processes, that's when you start getting in trouble. So if you've got a fast build and you can just know what the fix is, you can just roll forward.
So we've always roll forward now through. We do have backups, of course, in case something goes horribly wrong, but it's never needed to be used.
You've got feature flags, right? So hopefully a lot of that code will be in a feature flag that you can just turn off and patch and then roll forward.
So we've always, we have done patch, but generally it's roll forward.
We never rolled back.
Yeah.
So the worst comes to worst, we hot fix.
Yeah.
So
Even that though, the last time we tried to do that, then we just rolled forward.
yeah.
It's safer.
Yeah.
I think you're going to be too east.
The last question, Adam?
Yeah. Just wondering, with your build pipelines, with your end-to-end testing, is it pretty much a simple end-to-end testing, or are there a lot of applications that you're integrating with? And if so, do you have any flakiness or any issues around that?
The last meeting we didn't have too much integration, but obviously you do it. Integration is obviously a big, a big pain, a big part of most applications.
So we use like VCR is something we use. It's almost snapshotting a response from another provider. Obviously that's not always going to get you out of trouble if something you haven't caught, but generally happy days scenarios for our big long running tests, because if you start testing everything in your acceptance sort of test, you're going to not be able to release quickly because they're slow, and they can be flaky as well. So.
And also test in production. I know that sounds crazy, but use production data or production accounts to do some testing, and if you can, so use a dummy credit card, which only charges like 1 cent to actually make sure that it works.
Yeah. But you can pick the most important things to smoke test. So we've got smoke tests that basically do searches, views, properties, and booking, which is the most important thing for us. And they run during the build on pretty much every browser that we support. So Chrome, Firefox, IEs, certain mobile, and we pretty much say that's kind of like it. As long as that works, the rest we can deal with.
Cool. I think we'll just have to finish up there. Thanks to Brendan and Steve.
Probably good that that came before this, because this goes kind of more into depth on the CI part that comes in the middle, like before you actually deploy it with continuous deployment. So this is kind of an intro to how we've done CI at InfoExchange from a really crappy solution to what we have now. So
fail fast.
I'm a web application developer for InfoExchange. We're a not-for-profit. We do a whole lot of things in the e-health sector, but it's working now. We do so technology for social justice. Do digital inclusion, which is kind of getting people who aren't able to access technology to be able to access technology. Digital proficiency, which is allowing, training people to be able to use technology better, and digital empowerment, which is then getting those people that we've included with technology and made them proficient to actually use it to make their life better. Some of the stuff that we do quite a lot. We do S2S, which is electronic referral management. When you go into a doctor and you need a specialist, they refer you. Do QIPS, which is community healthcare project management. SRS, patient management. Service Seeker, which is a thing for Lifeline, a bunch of other things to help find services. Test IT, which is software testing, using people with Asperger's syndrome who are quite good at testing software. We do Job Seeker. Social design, we create low-cost websites and host them for not-for-profits. IT consultation, we do providing IT training and internet type stuff to public housing estates. There's a lot of stuff that we do. We do absolutely a lot. There's too much, and but it's all really good stuff. That's kind of about InfoExchange. So what's CI? CI basically, so agile means you do stuff fast. When you have a bug or a failure or something, then you're able to respond really, really quickly. And CI is kind of, I see it as facilitating that whole process. So in CI, you first off code something. Then when you're done coding it, you merge it into the main branch, so you integrate it. Then you test it. It's probably going to fail, but you test again, test. And then you fail more times, but sometimes you'll pass the tests. And then that comes on to the continuous deployment that they were talking about, but that's not what this is about. So that's test sometimes if you feel like it. That's kind of what most people, I think, tend to do. They don't really do the whole every time you change something, you test. You've got to be really rigorous. So why do you need to be absolutely rigorous in testing? Well, if you test every time you change something, then you know exactly what's broken your code. And you're able to fix it while it's completely fresh in your mind. There's no context switching at all. So if you're on a task, something breaks, then instantly you're able to know probably what happened. There's a whole lot more stuff, but that's, again, not really the point. Yeah, so if you're testing often, it means that your tests need to run really fast. Something like 45 minutes to go through your entire test suite is just not going to cut it if you're testing every time you push code. So inherently, you do need to test fast. You don't want your previous tests to mess with tests that you're doing now. So if someone else has broken something, you don't want their broken test to affect the code that you've just pushed. So you've really got to isolate everything from each other. So something like that kind of a bug, which is obviously oversimplified, but something like that.
No, it's not oversimplified.
Okay, it's not oversimplified, but yeah. So that kind of thing happens, and that will break tests and give you false positives, and it's just generally a bad situation to be in. So you want to isolate. You want to test close to production, because what's the point in testing in a Red Hat VM if your live servers run on Debian or something? It's just, or even something as simple as a minor version change or something can really break code. So you've got to test as close to your production environment as you possibly can, and that gives you way more confidence. So you want to fail quickly, because if you don't fail quickly, then yeah, there's a whole context switching. You've probably moved on to something else. So, how does the whole LXC, Puppet type stuff help with all of that? Well, Puppet lets you pretty much take your prod environment, or what your prod environment should be, and it lets you create a test environment, dev environments, whatever you want, that should be almost exactly the same as your prod environment. And you can just do that as many times as you want. LXC allows you to isolate stuff. So kind of like a VM allows you to have like multiple clones if you have your Puppet and your VMs. LXC is kind of the same, but a lot more lightweight. And AUFS allows you to almost instantly clone copies of your prod environment. So you can have 10, 20, 30, 40 copies of your prod environment, and you can just scale up dynamically. I'm sure all of you have heard of Puppet. Some of you have probably heard of AUFS, but LXC is probably a bit of something that not many people have heard of, or if you have heard of it, you have no idea what it is. But for those who haven't heard of AUFS, quick description. AUFS is a stackable unification file system, such as UniFS, which unifies several directories and provides a merged single directory. So basically what that means, is it combines multiple directories into a single directory. So you can overlay a whole lot of stuff. The first directory, or the first few directories, will be read-only, and the stuff that you change will get copied into a read-write directory. So you can create a whole lot of clones of a directory structure without actually needing to copy anything. And it's full read-write, and it just handles it really nicely. So on to LXC. The quirk that LXC has on their website is it's chroot on steroids, or VM Lite, something like that. I like to think it's kind of halfway between a chroot and a full-blown VM. It basically, it's a VM, but it runs stuff in your host's OS. So they share the process tree with your host OS, which means that it's incredibly light. There's no virtualization overhead or anything like that. You have virtual networks, so you can do interesting things like put a maximum speed on your virtual network and test how things will react on maybe a 56K modem if you feel like being ridiculous. It uses some cgroup limits, so if you want to, again, see how your stuff works on a really, really small scale server, you can deploy it with a whole lot of memory limits, that sort of thing. So there's a whole lot more things that it does do, but the main thing is that you can run multiple init processes on your one host. So if you've got, say, your VM that's doing all of your testing and everything, then you can have multiple inits, multiple processes, multiple servers. So you can have multiple inits, you can have multiple distros, so you can run a Red Hat container on a Debian host with almost no overhead other than actually running the applications. The only real constraint is that it's got to be the same kernel as your host OS. And that also means that you can run whatever version of Postgres you want. You can run them concurrently, so you can have 10 versions of the exact same Postgres listening on the same ports, but only the stuff inside the container will actually be able to communicate with that Postgres. So you can do some really interesting things with that. So yeah, they're using the same ports, same directories, so there's no sort of messing with directories or messing with port numbers for the sake of running multiple concurrent things in test, which can possibly cause problems. On the single host OS. Also, I may use libvirt and LXC in sort of switchable way because we use libvirt, which is basically just an abstraction layer for a whole lot of virtualization stuff, including LXC, and the line gets kind of blurred. I'm sorry about that. So they all run directly in the host processes list, which means that there's almost no overhead at all. So there's no virtualization, no real abstraction. They're all just applications that run in your process list. And that's pretty much what happened when I kept researching into all of this, thinking, how is this possible? It's crazy cool, and you can even do it in production. It's really good. So, basically, how I use all of this stuff to implement CI stuff where everything's up to date is I have a concept called base containers. Base containers are containers that are kept up to date with your prod environment via Puppet. So they are pretty much like a server. They're always left running on your CI server, and Puppet just keeps them up to date like Puppet does. So they're pretty much a clone of your prod in container form. They don't use AUFS for the moment, although you can use AUFS if you want to like merge a whole lot of shared stuff, like changing every container's host name, something like that. So you basically just use dbootstrap to set them up, or at least I did. You can use whatever Red Hat tool there is to set up a Red Hat environment, but we're Debian, so dbootstrap it is. So yeah, I use that. You can probably think of the base containers as kind of like a template or an AMI that's always running and always being kept up to date. So it's not a static image, it's kind of a dynamic image that you just don't have to worry about. Then there's temporary containers, which is pretty much where you do your all of your testing on. If your base container is your template AMI, then temporary containers are your instances. So you start up a temporary container based on your base container, which is always up to date. Have a really, really short lifetime, so you pretty much run tests, completely destroy them because they're highly disposable. So completely destroyed. Their file system is an AUFS file system, so you've got your base container, which you have as the read-only file system for your temporary container. You use that, so the AUFS combines your read-write directory for your temporary containers and your read-only stuff from your base container. So you've got a clone of your base container without actually needing to copy any files. And it's pretty much entirely instant to do that. So you can create entire clones with, like, it's under a second that it takes to actually do this. So yeah, they're highly disposable. You just remove the file system when you're done and it's gone. So this is the file system that is in a base container. So I have used AUFS here just because there's some extra stuff that we wanted to include. But mainly, I've included the libvirt shared stuff to override a few things in etc and add a few SSH keys, that sort of thing. But so as you can see, the root of the container is pretty much just a Linux file system in your host file system. It's incredibly simple. There's no like partitions, anything like that. The RW directory is just stuff that's changed. So there's quite a lot that's changed in this base container because I went from Debian and that's everything that's changed since base Debian. So this is the LXC config that, actually, sorry, not the LXC config, the libvirt config. So as you can see, memory clearly doesn't matter. We had memory problems where I accidentally put it as 100 meg, which is too low for Debian. But so yeah, pretty much you just start the init process and it just handles everything. So really the only things that you specify is here's where my root file system is, this is the network. You can put interesting network configs, whatever, it's all virtual networks and it just does nice things.
What are you running this on?
Pardon?
What's the hardware you're running on if you're allocating thousands of terabytes?
Oh, no. You can allocate thousands of terabytes. That doesn't mean it actually has thousands of terabytes. I just didn't care what the maximum amount of RAM that we had on the server was. So you can only go up to the maximum of the server.
It's not unlimited?
No, it's not. LXC's not that cool.
I mean, I know there's a couple of boxes available.
Yeah. If you did it on AWS, maybe you could do something crazy, but I'm not running on AWS. We're running on Blades. So yeah, the base containers are always running. And yeah, I didn't know how to show the Puppet config in here because I did something a little bit strange with Jenkins to run Puppet. But you can just trust me that it's keeping up to date. I'm not receiving any failure emails. So for temporary containers, it's pretty much exactly the same thing. So you've got your root file system, your read-write file system, and root is just combining the base container's root file system with this read-write directory. So there's your root file system, and that's pretty much just what's changed in the base container. So obviously you've got your logs in there and a few config changes in there because things like hostname need to change for temporary containers. It's pretty simple, and it's also kind of cool because if something logs to syslog, then you've only got what's changed in your logs. So, yep.
When it's doing snapshots, is it database aware? Can it tell a database make itself consistent before you?
How do you mean database aware?
So you're taking a snapshot of your base thing, you've got Postgres installed or whatever on it?
Yep.
Is a transaction running that or whatever?
No, I haven't taken into account transactions or anything like that. I'm just assuming, like...
Is there a script trigger or something you could use to do it? Or?
Yeah, you could do backup ready in Postgres and then take a snapshot.
But is that integrated to AUFS or is that separate?
So this is a snapshot, this is driver level.
Yeah. So I haven't done anything fancy with making sure that transactions are finished, that sort of thing. The only real safeguard that you've got on that is the Jenkins. How I've got Jenkins set up is Jenkins runs Puppet, and you can't run temporary container jobs until a Puppet run's finished, and Puppet doesn't start until. So they don't really interfere. They shouldn't. I mean, I guess they can, but then your tests will fail once, and then it'll be So yeah, if someone wants to solve that, I'd be more than happy to listen to a solution of how you do it. So things that change in the config, there's not really a whole lot. As you can see, the name gets replaced with just a randomly, well, not randomly generated, but that's pretty much just the name of the job and the build number. Yep. Source directory changes to your temporary containers directory, and your MAC address changed so that you get a new IP address. There's really not a whole lot to that. So I created this helper script called IX container. It does quite a lot of stuff, but it's absolutely horrible, as you can see there. It's written in Perl, which makes it horrible. It's buggy as hell. I didn't include kind of any try catch, anything. It's nasty.
C.1.
However, it is incredibly useful. It does a lot of stuff for you, even given all of that stuff. So it's mostly included in all of our automated stuff, which means that the buggy can be worked around and they're written in Perl and etc. We don't really care about too much. But it's also not open source because it's horrible. But that's okay, because you don't need IX container, because there's this fantastic thing called docker.io. Got released after I finished this. Literally about 2 weeks after I finished all of this. It pretty much implements that most of the LXC and automated stuff that I've done, but a lot better. So if you are planning on doing this, check out docker.io. It's incredibly awesome. And so for this particular case, DNS mask is actually really, really perfect. So when you start up a temporary container, you can just straight away ping it, because it gets its IP from DNS mask, and assuming you've got your DNS set to DNS mask, then you can just go ahead, ping your container, it's all just set up, everything works really nicely. That's a thing that libvirt comes with, just out of the box. So it starts up DNS mask, allocates everything, DNS works. It's really nice. So the secret source. Basically, this is the process for how all of this is working behind the hood in IX container. So you create your base container with your dbootstrap, and you just chuck it into a file system, a directory on your host. I had opt libvirt underscore whatever base container name. You create a libvirt config, as you saw before. It's just a fairly simple XML. There's not really a whole lot you need to change. Chroot into your dbootstrap environment and install SSH, DHCP, and sudo, because dbootstrap doesn't think that anyone needs any of those. So you define your container, which is basically saying, hey Versh, this XML is a container, please load it up and make it available to me. And then you start your container. And you can then from there SSH into it and install and configure Puppet, which should hopefully do everything else for you. Then step 2 is the cloning of Dolly Cheek or your container. So you make your directory structure. It's really just temp container and a root and read write directory. Not a whole lot to it. Use AUFS to mount the root directory, and that combines the read write and the base containers stuff. And then you should have your temporary file system. Copy the config from your base container, and as you saw, you just need to change the name, MAC address, and your root file system location to this/root. Update the host in etc hostname so that you don't have collisions in DNS mask, because they can be nasty. Much like the base container, define start. You can do that as many times as you want, so just rinse and repeat with that whole set of steps, and you can have 10, 20, 30 containers running as many as you want. And that whole process from not including actually starting the container and doing the init process, it's about 3 seconds worth. As soon as you actually init the container, obviously there's more stuff like DHCP resolution, that sort of stuff that you've got to wait for. But that's not really a problem. So from there, you can pretty much start doing your tests. You've got a container that looks exactly like a VM with almost no overhead, that's started up in a few seconds. So what we do is we check out our latest code. So every time we push to Git, there's a Git hook that tells Jenkins that there's a new commit. Jenkins starts a temporary container, checks out all of the code for us in the temporary container, build our environment. So we've got our virtual env stuff, and that just pulls everything down. We actually use some shared environment stuff so that we don't need to install it every time, which is good. Restart the app server so that all of your code changes actually take effect. Do your lit and style tests. Now, these tests run in a particular order, so you do your, to pay attention to the order. Lit style, unit tests, and then Selenium tests. Now, they're all going in that particular order because lit and style tests take like a second, maybe 2 seconds, something like that. Unit tests, also in the grand scheme of things, shouldn't take too long. Selenium tests, they're going to be slow as hell. So the idea with that is the fail fast. So if you've got a lint fail, you don't want to be running your Selenium test suites while something really, really simple is failing, because it's just going to go through them and then fail later. So, and run things in parallel, ridiculously parallel. We went from having about 15-20 minutes for our unit test to run, and as soon as you add one command line switch, -J16, to run 16 different jobs at the same time, that 15 minutes went down to about 45 seconds. So there's huge improvements just by running things in parallel. So once you're done with all of that, your tests have all passed, you can be confident because it's pretty much running in your prod environment. You stop and undefine your container, which means pretty much shutting it down and removing it from your libvirt stuff. You unmount your AUFS dirt. That's really important. Otherwise, like NFS shares, if you don't unmount it and you just delete endpoints and stuff like that, you get really nasty things happening and you can't get rid of it. And then that's pretty much it. You RMRF and you're done. And then you've tested all of your environment, you've tested all of your code, and you've got nothing left over. It all happens in like a few minutes, minus Selenium tests because they're crazy. Yeah, so Docker.io, everything but step 3 is pretty much covered almost automatically by Docker.io. There's some tying it all together, but yeah, so Docker.io and my IX container are pretty much the same thing. They just automated steps 1, 2, and 4. So anyone that uses Selenium hates it, but it's necessary. I'm still convinced that it's necessary despite what other people say. So the way we do that is we have XVFB on the host, so we're not actually running full-blown X environment on the server. It's close to it, but not quite. Or a Selenium grid. We don't do Selenium grid, but we want to. Selenium grid then allows you to test on Firefox, Chrome, Mac, Windows, whatever you want, just in parallel. It's kind of awesome. So multiple browsers can use the same XVFB. You only need one of them. You can have 20 browsers running in the one XVFB, just all going through testing different commits of your code. So Selenium hosts, if they use your DNS mask for the containers for their DNS, then you can pretty much just do what I did before with the ping and just say they can just connect to your container name dot your search domain, and it'll just find it really, really nicely. So yeah, as you saw before, we just had like Jenkins job whatever dot info exchange stuff, and you can open that in the browser and it just works. we had extra stuff that we had to do with socks, unless you have some ridiculously bad resolution of domains and instances and stuff, then like we did, then you shouldn't need to do that. You should just be able to hit it. So yeah, is there anything that you want to ask? I'm sure I haven't explained everything perfectly. Yep.
So obviously you're using the LXC containers. Did you look at other container systems, or particularly I'm thinking OpenVZ or only LXC?
I looked at, I can't remember if it was OpenVZ. There's one that came before LXC. LXC is kind of like the new kid on the block. It does a whole lot of new things, and yeah, it's hasn't, the previous one, the previous container system hasn't been deprecated yet. It's more stable, it's more secure. The only thing LXC really doesn't have from that is security. So you can break out of an LXC container really easily, but in this case, that's not really a problem.
What's expensive about your Selenium tests? Is it pushing things back into the database, or
everything? Selenium's really slow. You have to go through the whole HTTP post to various different virtualizations through the network. Selenium's just generally slow. Like if you have a look at the Selenium log, actually going from your code to Selenium it takes like 3-4 seconds, and then to actually go through all of the code path and everything. Yeah. So our Selenium tests for the product I'm working on take about 45 minutes, and we have very little coverage. I think Danny up the back there is working on another project. How long do your Selenium tests take?
Actually, after a revoke from the other day, about 20 minutes.
Oh, okay. Well, that's 20 minutes down from like an hour and a half or
About
something.
an hour and a half.
Yeah. So Selenium tests are always going to be slow unless you use something like Source, but yeah.
So in terms of, if you've got kernel modules, for example,
Mm-hmm.
that's not necessarily going to play really well.
Yeah, no, definitely won't work with kernel modules.
Well, you do, but you do need to make sure that you've got exactly the same.
Yeah,
version of
okay,
kernel.
yeah. So because everything actually runs on the host, they all use the exact same kernel. So you can't have, if you want to upgrade your kernel and test that stuff still works, it should. But yeah, that's not really going to play so well.
So when you take your root file system, if you take like a disk image and loopback mount that as the root file system, and then create a rewrite on top of that.
No. So the root file system, as in for the temporary containers or the base?
No, the base containers. Your base containers are.
It's just a directory.
Yeah, so the way I've got it is it's just a directory on the host. You could use like separate partitions, whatever you want to do. Or you could even have them on an NFS mount, whatever. Doesn't really matter too much. Yeah, so LXC just has to be able to pull files from them. Cool. Yeah. Danny?
I'm going to just tell you, I should have told you about this like weeks ago. You instead of being bootstrap to build your images, because you don't have to install a bunch of packages in config,
Yeah.
we want to call pbuilder. It's how
Yeah.
Debian builds its charoots to then build Debian packages. It does everything you need.
Yeah, I also stumbled across pbuilder after things. So, much like Docker.io, I would probably use that now. But
And for Fedora or Red Hat, there's mock.
yeah, okay.
So the reason I was asking about the database is that one of the guys who used to work for my school wrote a library called libdata.
Okay.
Libdata is very useful for testing environments. It replaces fzip with an O.
Right.
That's safe. If your tests fail, do you care about what hit this? Or are you just going to run the tests again and rebuild it? But if you have a failure of your test system that being stuck in the mid disk, do you care? No.
Well, there is that, but also if you have a no-op on your fsync, then you probably like. If you've got a large test suite that you also want to test the database, then you really do need to test the database. Like there's not, I can't see a whole lot of ways of getting around the database transactions thing, other than maybe, so anything that actually gets modified in the database by the temporary containers, AUFS will do a copy on write of your database and it'll just hopefully work. That's the idea of AUFS, so I'm trusting it. Yeah.
Is AUFS, that's like just basically the file, not the blocks or anything like that?
No, it's just at the file level. It's got a whole lot of metadata files that handles things like
So, it
deletion.
seems to change your 500 gig database.
Yeah, it will copy 500 gig. Yeah.
So what you're saying is don't have 500 gig in your base.
Exactly. Yeah. Yeah. So.
Because one would assume you wouldn't actually have Postgres running in your base, right? You don't want to turn it on the
I'm actually not sure. I don't think I've disabled it, but there's no reason to have it running other than if you want to just clone your whole file system, then you're going to have the same like init everything. So, yeah.
Do you do a Puppet run in the temp environments before you start off or not?
We don't. I do a Puppet run through Jenkins, I think it's once every 20 minutes. So the maximum that it can be out of date by is 20 minutes. And if something that happened in the last 20 minutes breaks everything, then...
So what I'm running is the base image of the code disable it and then the temporary environment code enable.
Yeah. So when we move to Puppet 3, which I think is happening pretty soon, our NOAA Puppet run will go from, a minute and a half down to a few seconds, hopefully, and then you can run Puppet every time you do something. But at the moment, a minute and a half is too much overhead for me to consider running Puppet every temp container run.
Is that it?
Yep.
Thanks, Ricky. There's a project called CoreOS, which is basically a Linux distribution that's just being designed for containers. So check that out if you want to play with Docker or anything.